This question comes from Mia, who asks, what would happen if everyone on Earth farted at once? At first glance, this seems like one of those classic funny but harmless questions. After all, people fart all the time, and the world seems to be doing fine. But when everyone farts simultaneously, things get interesting. Let's start small. The average human releases somewhere between zero point 0.5 and 2 liters of gas per day. Let's call it 1 liter for easy math. That gas is mostly nitrogen, hydrogen, carbon dioxide, methane, and a few sulfur compounds responsible for the smell. If everyone, 8 billion people, let one rip at the same moment, that's 8 billion liters of gas, or 8 million cubic meters. That sounds like a lot, but to put it in perspective, it's roughly the volume of 3,000 Olympic swimming pools. In other words, it's not nothing. But it's not enough to change the global climate either. However, the situation becomes more complicated when you factor in timing and location. Imagine all 8 billion people on land, spread roughly evenly across the continents. The collective release happens within a 1-second window, kind of like the world's most disgusting New Year's countdown. Locally, this could cause measurable effects. A single fart releases gas at around 3 meters per second. Multiply that by 8 billion, and you've got a brief, planet-wide pressure fluctuation, equivalent to a small gust of wind. Perhaps enough to move dust, ruffle leaves, or make sensitive microphones pop. The sound would be impressive too. A human fart averages about 94 decibels at the source, roughly as loud as a lawnmower. 8 billion farts, however, don't add together linearly. Because sound waves overlap in complex ways, the global mega fart would register around 120 to 130 decibels in the most densely populated areas, about as loud as a thunderclap or a jet engine. If you were standing in Times Square, it would be deafening. If you were in the middle of the Sahara, it would sound like a distant, inexplicable rumble. Now let's talk chemistry. Methane makes up only about 7% of the gas in an average fart, but that's still over 500 million liters of methane entering the atmosphere in one go. For comparison, that's about the same as what cows produce every few minutes. So, globally speaking, we've just had a very embarrassing but ecologically irrelevant moment. The bigger concern comes if the farts ignite. Methane is flammable and so is hydrogen. But for combustion to occur, you need the right mixture of gas and oxygen. Since most farts are dispersed immediately, global ignition is nearly impossible. Still, local ignition is another story. Imagine a crowded concert or soccer stadium when the event happens. Someone's lighter, a spark from an electric sign, and suddenly you've got a low-yield, extremely unpleasant explosion. It wouldn't level cities, but it would certainly make the headline. Let's say, for fun, we put everyone in one place, just like the everyone jumps scenario. 8 billion people, packed shoulder to shoulder, all farting at once. That would produce an enormous, dense methane bubble over the crowd. Roughly 8 million cubic meters of flammable gas rising into the sky. A single lightning strike could ignite it. The resulting fireball would be comparable in energy to several tons of TNT. Rhode Island would once again be destroyed. Even without combustion, the sheer odor would be catastrophic. Hydrogen sulfide, the compound responsible for the rotten egg smell, is toxic in high concentrations. You'd have a few minutes of confused laughter, followed by mass nausea, unconsciousness, and eventually, silence. On the bright side, the gas would disperse quickly. Within a few hours, winds would dilute the stench to normal background levels. Within a day, you'd never know it happened, aside from a few confused animals and some traumatized meteorologists. So, what would happen if everyone farted at once? For a brief moment, humanity would be united. 8 billion tiny trumpet blasts ringing out across the globe in a synchronized display of biological harmony. Then, the smell would hit. And that, Mia, is the day the world learned why synchronized flatulence should remain a theoretical exercise.